For the last part of section 11.3, we are going to talk about rotational symmetry. Now this is a little different than the symmetries that you've talked about in the past, where you take a shape and you cut it in half with a line, and if the shape is exactly the same on both sides of the line, you have a symmetry. We are going to do rotations. Now, for a shape to be symmetric through a rotation, what we're looking for is that when we rotate a shape, when we're done with that rotation, it looks exactly the same as it started. So did you notice that as we rotated that shape, it returned to its original position, but it had been rotated by a certain amount of degrees? The rotational symmetry will be the amount of degrees that we rotated to get that to happen. Now it's kind of difficult to tell exactly how far that was rotated, so I'm going to relate these rotations to something that we know, and that's a 360-degree rotation. If we rotate it all the way around, then it's returned back to its original position. And I'm going to see how many times that shape looks exactly as it started through that 360-degree rotation. Then we will simply divide that 360 degrees by the number of times that happened and figure out each of those rotations. Now it's kind of hard to tell when we've gone 360 degrees, so I'm going to pick one of the corners and I'm going to watch it rotate through and see when it returns back to its original position. So I'm going to pick this top corner right here. I'm going to watch it rotate once. Now it's right there. Twice. Now it's right there. 3 times. Now it's right there. 4 times. Now it's right there. And 5 times it has returned back to its original point. 5 times it happened that the shape looked exactly the same as it started when we rotated 360 degrees. So we'll calculate 360 divided by 5, and that will give us a rotation of exactly 72 degrees. So this one rotation from here to here is 72 degrees to get back to looking like it started. When you have a shape that's nice and regular, where all the sides are exactly the same, where all the angles are the same, in other words, a shape that is a regular polygon, then we can just simply count up the sides or the angles, which in this case is 5, and divide 360 by that 5. So if we did the same thing with a polygon that had 6 sides, we can see that it will rotate 1, 2, 3, 4, 5, and 6 times to complete a 360-degree rotation. 360 divided by 6 is 60, so this first rotation to get to be symmetric right there is exactly 60 degrees. I overshot it just a little bit. Is exactly 60 degrees. You might see some irregular shapes, in which case you'll just take a look and see the rotation that it takes to return to normal. Or you might get some pictures of things like arrows or stars or suns or whatever. So the strategy remains the same. How far do you have to rotate them in order for them to look the same? That is rotational symmetry. Thank you.